Hello, today we're going over 11.1 angle and line relationships, and I just want you to get ready for lots of kind of vocab-y type words that you're going to need to know. So starting off, we have vertical angles. And what a vertical angle is when two lines intersect. They form opposite angles called vertical angles. So here's my two lines, and they intersect there in the center. The opposite angles would be like this one and this one. Or this one and this one. The ones that are opposite from each other are your vertical angles. And these vertical angles are congruent. So they're the same thing. So if I were to label this 1 and 2 and this 3 and 4, 1 is congruent to 2 and 3 is congruent to 4. So that means they're the same. So if angle 1 was 110 degrees, angle 2 is also 110 degrees. Moving on down to adjacent angles. That is two angles that have the same vertex between them, share a common side, and do not overlap, are called adjacent angles. So they say it's like this, and then there's one more popping out here. So 5 and 6 here. Angle 5, I guess I should have put my angle symbols on everything too. Angle 5 is adjacent to angle 6. It's basically one angle split in half to make two angles. And it doesn't even have to be split in half. It's one angle split into two pieces. Complementary angles say if the sum of the measures of the two angles is 90 degrees, I left a little space to put a degree symbol there, the angles are called complementary angles. So if it's boom, boom, and our line coming out here, and there's our little square, those two angles will add up to equal 90 degrees. So if the sum, when you add them together, is 90 degrees, they are complementary angles. So say this was 7 and this was 8. Angle 7 plus angle 8 equals 90 degrees. The sum of the two is 90. And finally, we have supplementary angles. So that's telling us that the sum of the measures of the two angles is 180 degrees. So there's a straight line basically with another angle coming out. Angles 9 and 10 would add up to be 180, and that's supplementary. So complementary is 90, supplementary is 180. C comes before S, so C is smaller. The number is smaller, so it's 90. And our angle 9 plus angle 10 equals 180 degrees. Go ahead and pause if you need to get this done, but I'm going to keep moving on for the sake of time in this video. Next, we have perpendicular lines, and so that's when two lines intersect to create 90 degree angles. So that's like our line here, and it crosses through perfectly. So right here is 90, right here is 90, right here is 90, and right here is 90. So every single angle between perpendicular lines is 90 degrees. Now we have the paper problem. So in this problem, we have a piece of paper. Say that looks nicer than it is. We cut off a corner of this paper. So we'll change our color here to red. And boom, we slice that corner off. Now we have two different angles where we cut that piece off. We have an angle here, and we have an angle there. These two angles are supplementary angles, which means that they add up to be 180 degrees. We'll label this one Y and this one X. So if angle Y equals 135 degrees, we want to know what angle X equals. So since we have supplementary angles, these need to add up to equal 180 degrees. Y plus X will equal 180. So if Y is 135 plus X equals 180, you can subtract 135 from each side, and you end up with X equals 45. So our measure of angle X is 45 degrees. This next one I want you to try and do on your own and then compare with what I have and correct what you do wrong. So if angle R and S are complementary and R equals 65.3 degrees, what is the measure of angle X? So complementary angles add up to equal 90 degrees. Our R plus S will equal 90. If R is 65.3, sorry, that's awful, plus S equals 90, to get S all by itself, we subtract 65.3 from one side. What you do to one side, you do to the other, and I just wrote that backwards, 65.3. We cancel out and end up with S equals, let me get my calculator so I make sure I don't tell you the wrong thing, 90 minus 65.3 to get 24.7. So the measure of angle S equals 24.7 degrees. That's like the most perfect way that you can write it. Having that little M there to tell you it's the measure. We're now on to parallel lines, and I know some of you remember my joke, and some of you might not, so here it is. It's a shame that parallel lines have so much in common, wow, I even ruined it. Parallel lines have so much in common, it's a shame they will never meet. So it's two lines in a plane that never intersect. And what they have in common is that same slope. So it's two lines that are just boom, boom. They're never, ever, ever going to cross each other, even if they continue on forever and ever. A transversal is a line that intersects two or more lines in a plane. So now say we've got our two parallel lines. The transversal just cuts right through it. So it's intersecting those two lines. So it's a line that intersects two or more. There could be other lines going through, but the transversal is cutting through them. Now here's even more vocab words for you. I'm sorry. We're starting off with alternate interior angles. So what alternate interior angles are is they are on the opposite sides of the transversal and inside the parallel lines. So your exterior will be out here. It's on the outside of the lines. Your interior is in here. It's inside. So interior, inside, think like interior design. Exterior is outside, think the exit. So your alternate interior angles are like across from each other. So if we choose angle 3, its alternate interior angle, which it's also congruent to, if I can get my squiggly there, is 6. Angle 6. Because they're on the inside and they're opposite. So alternate is like on the other side. And those two angle measures will be the same. And 4 and 5 are also alternate interior angles. Our alternate exterior angles then would be those angles on the outside. So if angle 1 is one of them, the angle that's alternate, opposite to it, would be angle 8, all the way over there. And then 2 and 7 would also go together. So alternate interior angles, they're opposite of each other. What corresponding angles are, is they are in the same position on the parallel lines in relation to the transversal. So here, say we have angle 1. Its corresponding angle, which will also be the same exact measure, is 5, because they're both in the same location on their parallel lines and the transversal. They're both in that upper left-hand corner. So then 2 and 6 go together, 3 and 7 go together, and 4 and 8 would go together. In this one it says, in the figure, A is parallel to B, and Q and R are transversals. So this is A, this is B, this is Q, and this is R. So we've got angle, I have to draw in all my angles, sorry. So this first one says to classify the relationship between 3 and 5. So I've got 3 right here, and 5 is over here. So starting off, I'm looking at that, they're both on the inside of the parallel lines. And they're opposite, so they are alternate interior, because they're inside, angles. Then it says if the measure of angle 1 is 120, find the measure of angle 5 and angle 3. So this 1 here is 120. Which one can you look at and know exactly what its relationship is? Me looking at that, I know that 3 is opposite of 1. And if you go all the way back to the beginning of the slideshow here, we've got our vertical angles. They're across from each other at an intersection. So they're called vertical angles, and vertical angles are congruent. And if they're congruent, that means they're the same. So if 3 and 1 are vertical angles, then 3 has to be the same as 1. So 3 has to be 120 degrees. And then 3 and 5, guess what? We already said they're alternate interior angles. And alternate interior angles also have the same degree measure. So angle 5 is also 120 degrees. Go ahead and try this one on your own with our little angles in here. Angle, oops. And see what you get and compare with what I have. So it says to classify the relationship between angle 11 and angle 15. So we've got 11 and 15. Are they inside or outside? They're definitely outside. And they're in the same location on the, I guess one's inside and one's outside, right? The 11's on the inside and the 15's on the outside. And they're both in the bottom right-hand corner of their intersection point there. So they are corresponding angles. And remember, corresponding angles also have the same degree measure. So if the measure of angle 15 is 78.5, we want angle 11 and the measure of angle 9. So if 11 and 15 are corresponding angles and corresponding angles have the same degree measure, then guess what? The measure of angle 11 is 78.5. And now 11 and 9, they're opposite of each other in their intersection point, so they are vertical angles, and vertical angles are congruent, so that one is also 78.5 degrees. Finally, we have in the figure above, measure ABD And I didn't label my things here, sorry. A, B, C, D. So ABD, the whole entire thing, equals 164 degrees. We want to find the measures of ABC and CBD. So this entire thing adds up to equal 164. Our two angles added up together, the sum of them, will equal that. So we'll have 2x plus 23 plus x. Let's combine our like terms. So we're going to end up with 3x plus 23 equals 164. Now we just need to solve for x. So we're going to subtract 23 from each side to end up with 3x.
Jace Emery, please report to the Media Center. Jace Emery to the Media Center.
So 3x equals 164 minus 23 to get 141. Get x by itself, so you divide by 3. And you end up with x equals 47. We want our angle measures of ABC and angle CBD. So guess what? CBD here is x. So CBD is 47. Now we got to think a little bit here. If this angle plus our missing angle add up to equal 164, all we have to do is go something, so I'm going to put question mark, plus 47 equals 164. Now we're solving for question mark. So we're going to subtract 47. 164 minus 47 gets us 117. So our angle measure for CBD then, oops, I put those in the wrong place. Our angle measure for ABC then would be 117. Because adding those two together needs to equal 164. And on this last one, pause, try it on your own, and compare with me. It says angles RVT and UVW are vertical angles. What are vertical angles again? Oh yeah, they're opposite. So one of them's here and one of them's over here. So if RVT equals 3x and UVW equals 5x minus 36, how do we figure out the value of x? Well, vertical angles, what are they? Congruent. And congruent angles are the same thing. So that means 3x equals 5x minus 36. When we're solving with variables on both sides, we need to get only variables on one side. So what I'm going to do is, since 3x is already alone, I'm going to get all of the x's over there. So I need to subtract 5x. What you do to one side, you do to the other. So 3 minus 5 is negative 2x equals negative 36. Then we divide by negative 2, divide by negative 2. A negative divided by a negative is a positive, and 36 divided by 2 is 18. So we've got x equaling 18. And now we need to find the measure of UVW. So 5x minus 36 is what that is. If x is 18, we just plug in 18. So 5 times 18 equals 90 minus 36, and that is 54. So our measure of UVW, is 54 degrees. And then if it asked, what is the measure of RVT? Guess what? It's exactly the same angle measure as UVW. So the angle measure of RVT is also 54 degrees. Okay, you are on to your assignment for this section.